biology. So let's start with this. Okay. System of resistors arranged in series. Okay. Arranged in series. What is the meaning of series arrangement? One beside each other. Okay. Series. If somebody comes in the waiting room, I'll be checking that as well. Okay. All right. So how will it look like? Let's try to arrange it. So we'll have to draw the circuit diagram. Very simple. We will show how it is going to look like. So I'll start with at least 2 to 3 different resistors. Okay. Let this be my resistor number 1. Let this be my resistor number 2. Let this be my resistor number 3. Okay. They are connected to each other in a series arrangement. Okay. Now I'll have a bulb here. Okay. To show that the bulb glows. Why? The circuit is active. The current is flowing. Okay. Now what I'm going to do is, we did not arrange a voltmeter before, but now we will also be arranging a voltmeter here parallel to the system of resistors. Okay, we will take these 2 points as X and Y. Okay, next we'll draw the other important things. So I'll be drawing here the battery. Okay, the positive, negative, positive, negative, positive, negative, positive, negative. Battery is just one combination. Battery is a combination of 2 or more cells. Okay, battery is a combination of 2 or more cells. We have more than one cell here. Okay, it's a battery. Next, we'll have a switch or a key. People usually call it as a key. Now I'm going to place an ammeter here. I'm going to place an ammeter here, and this is my closed circuit. Obviously it should be closed. Now how to put the positive and the negative signs here? Very important. These are our resistors. Okay, these are the battery. I mean, this is the arrangement of battery. So the current flow will take place like this. Okay, now the bigger line is positive, the smaller line is negative. So the current through the ammeter flows from the positive terminal of the battery to the positive of the ammeter. So here we have a negative. So it will have to be a negative here also. Negative to negative, positive to positive. So this will be the plus. Okay. And the voltmeter is just going to follow the opposite of what ammeter follows. It will be a negative, sorry, not negative over there. It will be a positive over here and negative over here. Okay, this is the arrangement. All right, now these are your resistors. Let's check. Do we have somebody? Okay, we have somebody in the waiting room. Please switch on your videos. They're going to check. Okay, please do that. Yeah, because ma'am is going to enter. Okay, that's right. Okay, all right. Mom is joining, I guess. So yes, let's start with this then. Okay. All right. So here we go ahead with this. This much you understood, the arrangement. Now what are the things we will take up? How to derive. How to derive. So we have a system of resistors over here. Now we need to understand what is going to be the equivalent resistance of this whole circuit. What is this? This is a circuit diagram. So I'll write it using a different color of pen. It's a circuit diagram. Okay. All right. This is my circuit diagram. So what are the things that I will do here? Now I will just look at my circuit diagram and I will tell that nothing but the flow of current, okay, is same through each resistor. Okay, there is no change in the flow of current through all the three resistors. The same current will flow. If this is the resistor R1, the current I is flowing over the resistor number 2, which is R2. Again, I is flowing, and also in the resistor 3, the same current I is flowing. So the flow of current is same through each resistor arranged in series. Okay, right now, what is the position of the ammeter? This is ammeter. What is the position? It's over here. Even if I place it in between any of the two resistors also, for example here, still the measurement of current will be the same. Whether you place it here, whether you place it here, whether you place it here. Okay, there will be no difference. There will be no difference. Okay, understood? So in the series arrangement, the current flow will be the same. Okay, then what is going to be different? We are using three different resistors. So if there are three different resistors, suppose if the resistor R1 is of 2 ohms, if the resistor R2 is of 3 ohms, and resistor R3 is of 4 ohms, what happens? The total resistance will be different. All three are resisting the current in their own capacity. The capacity is different. So what happens if the current is same? Then what is different? The voltage is different. The potential difference measured across the terminals of the battery will be affected in each of the resistors. So if the flow of current is same in series, then what happens? What happens? The electric potential, okay, is different. So if the electric potential is different, the total resistance offered, yeah, I have a little bit of difficulty in writing it here. I'm a bit far from the system, but I'll try my best. The total resistance, okay, offered is the sum of, okay, sum of what? Sum of all the resistors emitting their resistance. So each resistor has their own resistance. So you'll just add all of them. That will be the total resistance offered by the whole circuit. Okay, emitting their resistances, individual resistances. The total will be the sum of the individual resistances. Okay. All right. Okay, very good. So this is what we have. Okay, the potential is different. The electric potential is different. The total resistance offered is sum of all the resistors, okay, of the individual. So how to express it? How to derive the expression? Let us write it down. So I told my total resistance can be R total. What is R total? My total resistance. Total resistance. Okay. Which is equal to what? R1 plus R2 plus R3. Perfect. Now, I say that I is same throughout. What is I? I is current. Is same throughout. Okay. So what happens? Voltage is different. So voltage in the first one will be, what is the relationship between voltage, resistance and current according to Ohm's law? I R1. Voltage of the first resistor will be I into R1 according to Ohm's law. We are following Ohm's law. Similarly, what will be V2? It will be I R2. Okay, what will be V3? IR3. Done. What is this? We are applying Ohm's law. We are applying Ohm's law. All right. Now, how to understand what is the total resistance, right? So the total resistance can be Rs. R total can also be called as Rs because it's in series. And then what we will do is, it is nothing but R1 plus R2 plus R3, right? R can also be expressed as V by I, but we don't need that. What we will do is, we will express V, okay, the total voltage as V1 plus V2 plus V3, right? This is the total voltage or potential difference. Then what we can do is we'll scroll down and derive it further. So it is V1, V2, V3. Now V total can be also written as nothing but, what is V1? It is IR1. So we'll just write IR1. What is V2? IR2. What is V3? IR3. What is V? V is IR, right? IRS, the total of all the resistors, which is equal to, I is common on the right hand side. I can take out I and all the others will become R1 plus R2 plus my R3. I can cancel I and I together and I will get Rs is equal to R1 plus R2 plus R3, etc. depending on the total number of resistors, since I have just used only 3 resistors. So I have applied Ohm's law and this is how you need to derive it. Okay, what is this? Equivalent resistance together. Let me just check if somebody's in the waiting room. Okay. I think Mahashri got disconnected. Okay. All right. This is equivalent resistance offered. Understood? We'll do the numericals. Don't worry about that. Okay. This is the total. So remember this formula. Okay. Remember this thing. Very important. In series, this is what you will get. This is what we have done also. How we got this? This is how we get this. Okay. Voltage will be this and I remains the same. So these are the most important points. Okay. We'll do the numericals after we finish the parallel. Okay. All right. So today we'll finish this. We'll also go to the heating effects and then we'll do this power thing. I think that's all is left out. Yeah. Okay. So let's scroll down. Let us study about resistors arranged in parallel. Resistors in parallel connection. Okay, let me tell you one thing. Okay, if the resistors are arranged in series, the resistance offered is more and more. So you can just say the resistance offered, okay, is very much higher. It's very much high. That's the reason, you know what we prefer. We prefer to arrange it in parallel because there are some disadvantage. Only that's the reason parallel connection has come up. So we'll study why it is. We'll study why it is. Okay. All right. So now we will take this up. Let us draw a diagram first for this to understand how to plot it. So I'm just going to draw it like this. This is one of my resistors. Then I have another resistor. Okay, I don't have much space, so I'll give some space. Okay. Okay, one more. I'm just trying to give a lot of space here. Okay, all of this is arranged in parallel. This is my R1, R2, and there is somebody in the waiting room. Just a second. Okay, Gautami is in the waiting room. admit R3. Very good evening, Gautami. I hope you're doing good. Gautami, we just started with parallel resistance. We finished the discussion of series. Okay, I'll explain you. Once I finish the parallel, I'll explain you the series connection. Okay, all right. That's how we will do it. And then you'll have a voltmeter also arranged. Your voltmeter will be here. Okay, and let's draw the other things, what we need to do here. So here will be my battery connection, positive, negative, positive, negative, positive, negative. That's all. This is my key. This is my key. Okay, now here I'm going to draw my ammeter. See, ammeter you can draw anywhere, that's your wish. I forgot to draw the bulb, so my bulb will be here, which is glowing. Why? Because my switch is on. Switch is called as key over here. Okay, now let me tell you one important thing, my dear kids. Over here, this is a parallel system. Why? Because the resistors are arranged in parallel connection or the parallel arrangement. So let us write this down. This is bulb. Okay, this is bulb. This is I. Okay, now this is the positive terminal of the battery, that is the negative. So this is the battery. Okay, this is the key. This is ammeter. Okay, this is voltmeter. So voltmeter to measure potential difference across the terminals of the battery. Okay, now let me tell you one thing. When the current flows, it flows from the positive end of the battery to the positive end of ammeter also, right? So this side should be the negative, this side should be the positive. Negative, positive. The voltmeter will follow the opposite of it. Here it will be a positive. And let me just do one thing. Let me just erase this. First I'll draw the negative sign, then I will write. Yeah, now I can write. This is the voltmeter. Perfect. Okay. What happens in parallel arrangement? We'll study that. Okay. Why is it important to study parallel arrangement and series arrangement? Because we need to understand which is the best to use. Okay. In parallel arrangement, what happens? I have three different resistors. Okay. The resistors are R1. Let R1 give a resistance of 2 ohms. Let R2 give a resistance of 3 ohms. And let's say R3 gives a resistance of 4 ohms. Okay, next. The resistors are these, R1, R2, R3, and what else we will see? So now let me tell you one thing. What happens to the current when it starts flowing? Once the current reaches this point, it will understand one thing, that there are so many arrangements, one below the other, below the other. So it should pass the current through all of them, right? So what will happen? I, which is your current, will be divided between the resistors, which means it will flow through all. The current is getting divided. Current will be different in all the resistors. Okay, current will be divided in the above arrangement. Current is not same everywhere. Current is not same everywhere. Then what is same? But voltage, or you can say electric potential difference. I'll just write it down. Okay, but the electric potential difference, okay, remains constant. Now you will think, okay, so this is the difference between them. Okay, so if current is different, what will happen? In the resistance R, I mean in the resistor R1, the current flow will be I1, which I'm showing in pink color, in I1. Then in in R1 you have I1, then you have I2 in R2, then you have I3, and so on, depending on the number of arrangement. Okay, all right. How to derive this? So wherever you put your voltmeter, it will still give you the same reading in parallel arrangement, right? So we have some activities. We'll watch all those. Do not worry. Once we do it, let us do the derivation part of this. Let's see. So what is the resistance, total resistance provided? Total resistance provided will be R1 plus R2 plus R3, but not exactly. So we'll see how to derive. This is not the exact thing. We are doing it for parallel. So it won't be that. Okay, it won't be that. Let's start with I, current flow, right? So I1 will be what? What is the Ohm's law? We know that V is equal to IR. This is our Ohm's law, right? Very famous Ohm's law. Over here, I want to write I. So it can be nothing but V upon R1. Voltage remains same. So I am taking voltage as V itself. I'm not doing any kind of changes over there. Okay. So what is I2 then? I2 will be V by R2. What is I3 then? V by I3. Sorry, R3. Okay. All right. Voltage is same. Resistance is different. Current is different. What do you think you can do here? So let me tell you one thing over here. You want to get the value of it, right? So the total current I is nothing but I1 plus I2 plus I3, right? This is the total current, I total. Okay, and we also know that I is equal to V by R, and we also know that the total I is V by R. Resistors are arranged in parallel connection. So what do we do? So I is actually equal to nothing but I1, I2, I3. So what you will do is again write it down. Okay, now just replace few things. Instead of I, replace it with V by R. Instead of I1, replace it with V by R1. In place of I2, replace V by R2. In place of I3, replace V by R3. Done? Take out the common terms. What is common? V is common. Take V outside. It will become 1 by R1. Take V outside everywhere. In maths, we have learned it, right? When we take common terms. Sorry, this is not R1. Sorry for this. This is just R. Okay. That was just an R. This is R1. Okay. You're taking it common, right? So I'll just make a square bracket. R2, 1 by R3. Okay. Done. I can cancel my V and V. So 1 by Rp. Why Rp? Rp is nothing but to show that the resistance in parallel, okay, is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Done. This is the equation that you need to derive. That's how you derive it. I've already shown you how to derive. I'm just going to highlight this point over here, everything over here. Okay, very, very important. Okay, we understood this. Now, since Gautami joined a little bit late, we will explain her the series, the formula. We'll do the numerical questions. Then we'll go to the heating effect of electric current today. Okay. All right, let's scroll up. Okay, so Gautami, we started with the system of resistors today. Okay, and what we did here is first we started arranging them in series. When we started arranging them in series, what happened is we take all the three resistors and arrange it in one line after the other. I mean, one beside each other. Okay. And we see that when the switch is on, switch is nothing but key. We call it as key. When it is switched on, the bulb glows. How the bulb glows? The current will flow through it, right? Okay. We also have resistors which will prevent the current to flow to some extent through the circuit. Now we have drawn the battery arrangement, ammeter arrangement, voltmeter. I forgot to write here. This is voltmeter. Okay. And etc. Right. So these are the things that we have. Now what you will do here is nothing but you will derive it. You have three different resistors, let's say 2, 3, 4 ohms. And then the R total will be equal to total resistance, which is equal to R1 plus R2 plus R3, which is also written as RS. Why? Because the resistance offered by a series system is different, and it's the sum of all the resistors emitting their individual resistance. Current is same throughout. Then what is different? Voltage is different here. According to Ohm's law, V is equal to IR. So RS will be R1 plus R2 plus R3. Okay. Now instead of writing that, we can also write V. We will write V, which is equal to V total, which is equal to V1 plus V2 plus V3. And then instead of V1, we replace it with IR1. V2 will be IR2. V3 will be IR3. Then we cancel the current together. We are left out only with the resistances, and we add all of them. We add all of them to get the answer. So that's all about. So in a parallel, what happens? Current is different. But voltage is the same. Okay, remains constant. So these are the things that we have studied today. We'll do the numericals. Okay. So I'm just going to take it from the textbook itself. Just give me 1 second. Okay, 1 second. Okay. I'm going to give it to you. And you don't have to worry about it. It's a good question. Everything is easy, only not too difficult. Take a snapshot of it. Example 12.7. Okay. I'll also give the figure which they have given it to us. Can I paste it here? Any chance? Unable to paste it again. Oh yeah, it's here. It came over here by mistake. No problem. Let's delete one of them. Yes. The other one is here. I'll just take this one and bring it here. Yes. Okay. This is your question. We'll expand this. Okay. I'll get the diagram as well. Don't worry about that. Okay. So 1 second. I'll get the diagram. Don't worry. Because it's mentioned over there as seen in the diagram. Okay. So that's why. Done. Okay, let's read and understand the question. It says, an electric lamp whose resistance, okay, an electric lamp whose resistance is 20 ohms. This is one device, and a conductor of 4 ohms resistance are connected to a 6-volt battery. This is your battery here. Okay, this is your battery, this is your bulb. Okay, or lamp. You can also call it as lamp, whose resistance is 20 ohms. Whose resistance is, you can say R1, which is 20 ohms. This is your conductor, which is having 4 ohms. What is this? Conductor, and this can be R2. This is your conductor. Okay, next. This is the battery. Okay, next. Calculate. The first part A. You need to calculate what? You need to calculate the total resistance of the circuit. So let's do the first part first. Okay. So we need to calculate what? The total resistance. Which kind of arrangement is the bulb and the conductor? They are in the series arrangement. Okay. So how do you start writing the answer for this? You will say the solution part starts like this. You can say that the given system of resistors, okay, is in which arrangement? They are in series arrangement. Series arrangement. Okay, so if they are in series arrangement, what happens? The total resistance is equals to R1 plus R2, right? Okay. Now what happens after this? After this, we have to calculate the total resistance. No, so this is the formula. So let's calculate it. This is the part 1. Okay, RS can be your total resistance or equivalent resistance in the series arrangement. You can just say total. See, total is nothing but it is also called as equivalent. Okay, total resistance, which is equal to equivalent resistance, is equal to R1 plus R2. What is R1? The resistance of the bulb or the lamp, which is 20 ohms. You can also put it in chats. Okay, it's not that when I'm doing that time only you have to. If you have finished doing it, good job. Okay, 20 plus 4, 24 ohms is the answer. Okay, total resistance done. Next part of the question is the current through the circuit. Current remains the same. Let's calculate the current through the total of it, right? So we will scroll down and find it out. You need to find out the resistance, right? So how will you find the resistance? The total voltage is how much? 6 volts. Voltage is nothing but potential difference, right? So you need to find out the current, which is I. Using Ohm's law, V is equal to IR. I will be what? V by R. Okay. V is what? 6 volts given. Potential difference R total or RS. 6 upon 24. Okay. What is 6 by 24? 1 by 4. What is 1 by 4? 0.25 ampere. Ampere, that's the unit. 0.25 ampere of current is flowing. Okay. All right. See, you need to remember these things. You need to do these things. Okay. Now, just give me a second. Okay. What else? What else? C. What they have asked in C, let's see that. The potential difference. So let's calculate the potential difference across the electric lamp and the conductor. Potential difference is going to be different. So let us calculate that. How do you do that? V1. V is equal to IR, right? So I will be constant. You have R1. Okay. Then you have to calculate V2 separately. I, R2. Okay. I is how much? 0.25. See, some people, what they do, they will keep it in fractions also. If it's easy for you to keep it in fractions, you can do that. You can do that. Let's do it like that. Let's do it like that. It'll be easy to cancel. Okay. All right. What is R1? It is 20. Okay. How much is it? 20 by 4, 5 volts. Now what is I? I is again 1 by 4. What is R2? It is 4. So how much is it? 1 volt. So V1 is through which device? It is through a lamp. And V2 is through conductor. So when you calculate V1 and V2, you should get equal to 6. So 5 plus 1 is a 6. Yes.
Sorry
please.
to interrupt, but it should be strictly followed. If the students' video are off, they should be removed from the group.
Oh,
It
okay.
is
Actually, they
mandatory that
switched it on, ma'am, but again, I think they have switched it off. Okay.
yeah,
I'll just check them
please
out.
be little strict. If they're off the video, then just remove them from the group. Again, they cannot join this class.
Okay, sure. I'll do that.
Please, students, remember
Please.
that once it is
Yeah.
removed by host, you people cannot join today class. Just make sure you on the video.
Yes, please switch on, all of you, your videos. Okay, please do not keep it switched off at all as per the instructions. Okay, so even if I start taking classes, you should not switch it off. Okay. All right, I'll be monitoring that. Okay, hello.
Okay,
We
ma'am.
have Gautami. Yes, Gautami.
Gautami,
On your video, Gautami. If you can hear us. Before I go ahead, there's a chat. Just a second. Yes, Gautami, please switch it on as per the instructions. Because why is it important? Because we'll be seeing how much you are concentrating. Only then it will be beneficial to take classes, right? Otherwise, it's just me. I'll just keep speaking, right? Yes,
ma'am, just
Gautami.
because
Can you
so many parents have complained that you guys are just taking the class. What our
Okay.
students are doing, you guys never know. Please switch on the video so that if they switch to some other app, also their video will turn off, so that you can easily understand.
Correct. That's true. That's true, ma'am. Thank you so much for that. Yes, we have everybody's video on. So anytime you enter any class, it's not just science, any class from our, institute, especially, please keep your videos switched on. Okay. All right. Please do it and be attentive. Okay. So ma'am will be, monitoring. If ma'am is not there, I'll be there. So I told you, right? Keep it on. Okay. All right. So don't do that. Yeah. Because we have got complaints. That's why. Otherwise, we were not making it mandatory. Okay. Let's come
Okay,
back to
ma'am.
this. Okay. Let's come back to this. Okay. Where are we? We have, see, if you have to go somewhere in between, just tell me and then go. No problem. That time you can switch it off. That's okay. Okay. Let's finish this. What is V1 and V2 if you add together? It will be what? It will be how much? 6. You're getting 5 plus 1 as 6, no? So that's correct. So your calculation should be correct. Okay. All right. Done with this question. Let me bring the next question for you. So let's bring the next question. Okay, let's bring the next question. So ma'am will come, and the best thing is the recording is going on. Okay. So please don't do that. Okay, please don't do that. 1 second. Let me go to the next question. Okay. So we have only till here. Let's take up the next question. 1 second. Okay? I think. Uh, 1 second. Okay, no problem. Okay, I think Gautami and okay, you joined a little bit late, right? So okay, no problem. That's okay. I was just seeing those things. Let me just give you the question for parallel. Okay, for parallel one. So I want you to tell me how will you do this? We have studied it. Okay, let's finish this fast and we'll do the other things today. Okay. The question comes up here. Okay. Let me admit Mahashri. See, if you have network problem, okay, you can just let me know. But please keep it switched on. Okay, it'll be for you itself. 1 second. Just scrolling down. Yeah. Okay. If you all are working so hard, okay, do not worry about that. Okay. Just be attentive. That's more than enough. And just 1 hour I'm going to give a lecture to you, right? 1 second. Let's keep it here. Okay. There's a chat. 1 second. Okay. So recordings will be going on. Okay. Do not worry about that. 1 second. No problem. That's okay. But Mahashri, that's all right. But please be on time. Okay. And we'll finish it together. Okay. Otherwise, what happens is it keeps just going, getting lagged. Okay.
Can you please scroll up, ma'am, a little bit?
Okay, I will do that. 1 second. Yes, finish writing. No problem. Okay. No problem. Okay. So we are almost few more topics are left out. That's all. Okay. Yes, once you finish, do tell me. In the meantime, who would like to solve this? Anybody who is already trying to solve this? Yes. Okay, try it out. Yes, Mahashri. Yes, please switch on your video. Yes. Make sure you do that. Okay, make sure you do that. If you have to go anywhere in between, tell me and go, no problem. That's okay. All right. Yes, tell me, how are you going to actually do this question up? Yes. What do you think this question is for? Yes. Do you have a figure here? No,
No,
I'm
ma'am.
not giving you the figure, no? Yes, so you should tell me, ma'am, there's no figure. Then how do I identify whether it is, series or parallel? Okay, I will give you the figure. I'm just searching for it. 1 second. 1 second, 1 second. Oh, okay. They haven't given the figure here in the textbook actually. They just told figure 12.10, right? 12.10. I'm searching for it. Okay, don't worry. Yeah, I got it. It's the activity figure that they are considering. Okay. No worries. Let us come back. Here is the figure for you. Can you see it now? Yeah. Now you got the figure. So which kind of arrangement is it? Parallel. Parallel. How will you do this? What do you think? How can you do this? Oh, sorry. Yes. What should we find out? Let's focus on that first. Quickly. Okay. They are telling in the circuit diagram, okay, given in the figure 12.10. This is figure 12.10. Okay. Suppose the resistors R1, R2 and R3 have the values of 5, 10 and 30 ohms respectively. R1, R2, R3. Let's write the given information over here. Okay, let's finish this. The given information is R1, is 5 ohms. R2 is 10 ohms. Okay, R3 is 30 ohms. Right? Very good. Which have been connected to a battery of how many volts? 12 volts. Okay. What's the voltage? 12 volts. Okay. Very good. Now you will tell me that even in the series connection, they didn't give us the voltage separately. They will not give you separately every time. You have to identify by looking at the figure. Okay. If they don't give you the voltages, that doesn't mean that series connection will have only one voltage. Every resistor will have a separate voltage. Similarly, in a parallel connection, every resistor will have different current, but same voltage. Okay. All right. This is going to be same or constant throughout. What are you supposed to calculate? Quickly, we will calculate the current first through each resistor. So I1, I2, I3. Okay, let's write it down. Current through each resistor. I1. What is I1? Formula using Ohm's law. V is equal to IR. I will be V by R. So V by R1, because this is for the first resistor. V is 12. What is R1? 5. Okay. All right. In ampere. Keep it in fractions. It will be helpful. If you want, you can, use and then do it. What is 12 upon 5? It will be 2 point something, right? 5 fours are, sorry, not 5 fours are, 5 twos are. Okay. I'm just monitoring all of you. Okay. Yeah. That time I was busy in teaching, but now it's important since you might switch off your cameras. Yes. So don't do that. Okay. 5 twos are 10.
2.4.
Okay. Very good. Very good. 2.4 ohms. If you want, sorry, not ohms, ampere. It's current. It's current. Very, very careful. Okay. Be very careful. Next, quickly. I2. What is I2? V by R2. V by R2. What is V? V is equal to 12. What is R2? R2 is how much? 10. Right? What is 12 by 10? 1.2. Very simple. This was quite simple, right? Decimals. Anything divisible by 10, right? Let's erase the rough work. Very good. Now, I know all of you can do it really well. Okay. And if you have any doubts, to let me know. Okay. I'm taking it very easily, very slowly. I'm not rushing with anything. Okay. I3, V by R3. I3 will be equal to V by R3. 12 by, what is R3 given? 30. Okay. Chalo. Right? What is 12 by 30? You can simplify it. Both are divisible by 3. Right? So it will be 4 by 10. You can still simplify it. 2 by 5. 12 and 30 divisible by 6 also. So 2 by 5 ampere. What will be the decimal form of it? Let's write it down. 2 by 5. So 5 zeros are 0. It will be 0.4. Okay. This is 20. 0.4. That's a 4. Okay. 0.4 ampere. Okay. Dear students. All right. Next, what will happen? We are done with the current calculation. What is the next step? They are telling us first, calculate the current through each resistor. Now they are telling us calculate the total current in the circuit. So you'll just add. Okay. All right. And then you have to find the total circuit resistance also. Total current and the total resistance. Okay, let us scroll down. We'll finish it here. 1 second. Yeah. So what is I total? Quickly add them. That's all. Just add them. I1 plus I2 plus I3. You can use your fractions also, or you can use the decimals. Anything that you're comfortable with. 2.4 ampere plus 1.2 ampere plus 0.4 ampere. How much is that going to be? It is going to be 2.4 plus 1.2 is how much? 3.6. Very good. 4 ampere. Okay, lovely. Very great. Good job. So 4 ampere is the right answer. Great, great, great. Now what else? The part C. Resistance. It's in parallel. What is the formula? 1 upon RP. Let me see your videos. Okay, it's on. Yes. So 1 by RP is how much? 1 by R1 plus 1 upon R2 plus 1 upon R3. Why? Why only till 3? Because we have only 3 devices, 3 resistors. Just write down their values. That's all. So 1 upon R. You don't have to derive it. Just remember the formula and then, work on it. Okay. 1 by R1. What is R1? R1, R1. We'll see the value of it. We have written it as, okay, 5, 10, 30. All right. 1 by 5. 1 by, what is that? What is that? I forgot to see. I'll have to scroll down. That is a little bit of, time consuming. 5, 10, 30. There's a chat. RP means, yes, RP is nothing but resistance in parallel. Just like RS is the resistance in series. Okay, RP means the total resistance in parallel. That's what I said. Okay, resistance in parallel. Okay. Now what's the next? 1 by 30 it was, right? Okay. I'll just quickly check because I'll scroll up and check. Yeah, 5, 10, 30. Very good. Now tell me, how do you do this? We take LCM, no? We take LCM. What is the LCM of 5, 10, and 30? It is 30 only. LCM of 5, 10, and 30 is 30 only, no? Yeah. We take LCM of denominators, right? Okay. It is 30. Why? 5, 6 are 30, 10, 3s are 30, 31s are 30. Lowest common multiple. So next what happens? It's already a 6. They might have any other class. No worries. We have few small topics left out. The power thing and the heating effect. It'll be done tomorrow. It'll be completed tomorrow. Next class, we'll discuss the questions. And in August itself, we'll start with the biology chapter. And as I said, for extra classes, we might schedule it from, I think, maybe this month, last week, or maybe next month onwards for extra classes. Don't worry, we'll try out. Okay, let's quickly finish. LCM is 30. So the total LCM will be your 30. You know that. What happens? 1 into, okay, 5 6s is 30. So 1 into 6 plus 10 3s is 30. So 1 into 3 plus 31 is 30. So 1 into 1. No need to change that. So we have 6 plus 3, 9. 9 plus 1, 10. 10 by 30 is 1 by 3. So what is RP? RP is not 1 by 3. RP is, just take the reciprocal. It is 3. It is 3. You're taking the reciprocal. It's 1 by RP. 1 by RP is 1 by 3 ohms. So RP is equal to 3 ohms. Okay.
Why we should reciprocal, ma'am?
Why we should reciprocal? So if you tell that 1 by RP is 1 by 3, that's correct. So will you tell that the value of my 1 by RP is directly 1 by 3? They are asking you the total resistance. This is reciprocal of resistance. So will you write your answer like this? Is it acceptable? It is correct. It is not incorrect. But is it acceptable? Do you really think? No. Why should we do reciprocal? Because it is 1 by something. Right? So you are just comparing the denominators. Numerators are same, no? 1 by something, 1 by something. That's all. Just like you have 1 by x is equal to 1 by y. So what do you say from this equation? X is equal to y in maths. Similarly, this is also you have the same thing. Okay, suppose it was 1 by RP. If it was 5 by 3, Then what would have been your RP? Quickly tell me.
3, ma'am.
Just 3? Is the numerator same? It is 3 by 5. Reciprocal it. I'll write here. Okay, note. Take the reciprocal of it. Okay, you have to take that. You can't leave it like that. Okay, take the reciprocal of the answer, especially for parallel, because it's 1 by something. Okay. All right. So if you need the recording of anything that you missed out, it will be sent. Not a problem. We are ready to do everything that helps you out. Okay. Now let me tell you one thing. What is the disadvantage? I'll just tell you quickly. The disadvantage of placing the resistors in series is that they consume a lot of energy, which is nothing but a lot of current is required. So to avoid that, they started keeping it in parallel, and there are more points which we will easily discuss tomorrow. Then we'll do the heating applications of current, like whatever current that passes through the circuits, what is it used for, right? The current will flow when the electrons move. So what will happen when the current flows? Is it doing something? Yes, it is helping you to switch on the fan, switch on the geyser, switch on the TV, any electrical appliance, right? So why is it important? How much work is done to switch on a bulb, etc. That is all related to your power. Okay. All right. Any kind of questions before you leave?